Assalamualaikum everyone. In today's episode, we analyze part 1 of test questions involving geometric optics, specifically on the concepts of image formation by plane mirrors and curved mirrors. Stick around till the end of this video to complete all the 8 questions. So just sit back, watch and learn. Question number 1. When a virtual image is created in a plane mirror, all of the observations below are true except option letter A, the reflected rays diverge. Option letter B, the image is located behind the mirror. Option letter C, the reflected rays are all parallel. And option letter D, the image is upright. Alright, the correct answer is option letter C. The reflected rays are all parallel. Here is our explanation to question number 1. In this figure, we illustrate how the image is formed by a plane mirror. The object is represented here by an arrow colored blue. Its height is HO, right? And is located at distance DO in front of the plane mirror. Okay? The reflecting side of the mirror is assumed to be facing to the left. So, when an incident light ray from the tip of the object, right, hits the surface of the mirror at point C, right, the way it hits the mirror is such that it is perpendicular to the surface of the mirror. So, when it is reflected back, right, the reflected ray is just in the opposite direction, right, along the same path as the incident ray. Now, when another incident ray, all right, starting at the tail of the arrow, which is representing the object, also at point A, so this incident ray, when it hits or strikes the mirror at point C, it forms an angle theta I, known as the angle of incidence, so that when reflected from the mirror, right, it is reflected towards point D, forming this angle theta R, known as the angle of reflection. All right, so notice that the two reflected rays are not parallel, right? We say that the two reflected rays tend to diverge away from the mirror. Right. So the term is diverge. They are not parallel. And when these reflected rays are extended beyond the mirror, as represented here by the broken line, right? Then we will be able to locate the image of this object form behind the mirror, right? So the image here is represented by this broken arrow with a height hi, and you will also notice that it is uh, upright or erect, just like the object, right? And since it is formed behind the mirror, that's why it's called a virtual image. And its size is just the same as the size of the object. That means hi, or the height of the image, is just equal to ho, the height of the object. All right? Earlier, we mentioned about the distance of the object from the mirror, represented by do, while uh, the location of the image, all right, is also or has a distance di, whose magnitude is just equal to the value of the object distance, right? The only difference is that if do is positive, di is negative, right? So with all these descriptions of the image formed by plane mirror, plus the fact that the reflected rays are not parallel, but they in fact diverge away from the mirror, okay, that explains why our answer to this question was option letter C. Question number 2. The shortest plane mirror in which you can see your entire image, option letter A, is half your height. Option letter B is equal to your height. Option letter C is twice your height. And option letter D depends on how far the mirror is from you. Correct answer is the shortest plane mirror in which you can see your entire image is half your height. Alright, so this is how we are going to explain uh, the question or the answer to the question. Okay, we will assume that um, your height is 160 centimeters. Alright, and to begin with, okay, we also assume that the vertical height of the mirror is just the same as your height. And also, we say that uh, your eyes are 10 centimeters below your forehead, all right? While your feet are 150 centimeters from your eyes, assuming that you are standing on the floor, all right? So, uh, we know that there is an infinite number of incident rays that we can choose. But for simplicity, we'll just choose an incident ray such as incident ray number 1, this is coming from your forehead. All right. So when it strikes the plane mirror, all right, exactly at the point, midpoint of the distance from your eye level to your forehead, all right, that's exactly 5 centimeters. And when reflected, all right, following the law of reflection, angle of incidence equals angle of reflection, the reflected ray for this incident ray number 1 is exactly towards your eyes. So that's the reason why you'll be able to see the image of your forehead, all right? Uh, the reflected ray, number 1, when extended behind the mirror, as shown by this broken line, all right, it locates the image of your forehead. And that is a distance equal to uh, the object distance. In other words, if you are, for example, 1 meter away from the mirror, all right, your image in the plane mirror is also 1 meter behind the mirror, all right. And also, we choose another light ray number 2. This is coming from your feet, all right. So when it hits that point there, exactly uh, 75 centimeters, that's half of the height or distance between your feet and the floor, or no, that's the distance between the eye level, all right, and your feet. So that's 75 centimeters. So again, applying the law of reflection, angle of incidence equals angle of reflection. So when reflected, all right, the reflected ray for this ray incident ray number 2 is of course exactly towards your eyes. That's why if you look at this point, all right, exactly at 75 centimeter point, then you will also be able to see the image of your feet, whose distance behind the mirror is also equal to the distance of your feet from the mirror. In short, this entire image represents your whole image, all right? So in other words, if you are 160 centimeters, your image also appears to be 160 centimeters. Now, you will notice that there is really no need to have uh, a mirror whose vertical length is equal to your height, all right? And we take note of this portion of the mirror that's needed, okay, for you to be able to see your entire image, right? So we emphasize that. What is this distance? All right. It is in fact equal to the vertical height of the mirror, which is 75 centimeters, okay, plus the 5 centimeters here, for a total of 80 centimeters. So that's exactly half of your height, right? There is no need to have a vertical mirror that is or that has a length, vertical length equal to your height. All you need is the smallest, right? The smallest or shortest plane mirror that you can use for you to be able to see your entire image is just half your height. But you've got to position this plane mirror, all right, 75 centimeters above the floor, right? So if the mirror is positioned lower than 75 centimeters, then you won't be able to see your forehead through this mirror. Or if the mirror is higher than, if the lower part of the mirror is higher than 75 centimeters, then you won't be able to see the image of your feet either. So it has to be exactly positioned like this, 75 centimeters above the floor. Question number 3. An object is placed 1 meter in front of a plane mirror. An observer stands 3 meters behind the object. For what distance must the observer focus his eyes in order to see the image of the object? Option letter A, 1 meter. Option letter B, 3 meters. Option letter C, 4 meters. Option letter D, 5 meters. All right. So let us first show the diagram. So if this vertical line is the plane mirror and this is the object that happens to be 1 meters in front of the plane mirror. All right. So an observer is standing 3 meters behind the object. All right. So the distance between the observer and the object is 3 meters. All right. Now we already know that the distance of the image formed by the plane mirror is just equal in magnitude to the object distance. So that if the object distance is 1 meter, then the image distance is also 1 meter, but behind the mirror. All right? And the question, what distance must the observer focus his eyes in order to see the image of the object? So for this particular observer, right, how far is the image? All right? How far it is from him? All right? Because that distance is going to be the distance that he must focus his eyes, right, to be able to see the image in the mirror. So our answer is, of course, option letter D, 5 meters. Why 5 meters? All right. The observer is 3 meters away from the object, but the object is 1 meter from the mirror. All right. So we now have what? 3 plus 1, that is 4 meters, plus the image distance of 1 meter for a total of 5 meters. Question number 4. Which one of the following statements concerning a convex mirror is true? Option letter A. It can form a real image. Option letter B. The image is always inverted relative to the object. Option letter C. It must be spherical in shape. And option letter D. The image is always reduced in size. And our answer is option letter D. The image is always reduced in size. That is the only correct statement. Options A, B, and C are all incorrect. All right? We have the explanation in just a short while. All right? So let us first illustrate how the image of an object is formed by a convex mirror. All right? So here is the object which is erect or upright to begin with, right? And um, it is located, all right, between the center of the convex mirror and the focal point or the focus, right? And to be able to determine where the image is going to be located or formed, all right, we first um, imagine that there is an incident ray coming from the tip of the arrow representing the object, right? So this incident ray number one is parallel to the principal axis, all right? This horizontal line is called the principal axis, which connects the center, the focus, and the vertex, the mirror, all right? So what's going to happen to this parallel incident ray when it hits the surface of the convex mirror, all right? So it's going to be reflected, all right, along that direction, okay? And we need another ray still coming from the tip of the arrow that represents the object. This time, we are choosing an incident ray, all right, that will hit the vertex of the convex mirror, all right, which, when reflected, it's going to be reflected as shown, all right. The incident ray forms an angle of incidence, while the reflected ray forms an angle of reflection. And these two angles must be equal, right? Now, uh, if the reflected ray number one is extended backward, all right, it must pass through the virtual focus. This point here is what we call the virtual focus of the convex mirror, all right? The extended um, line represents, okay, the virtual reflected ray. Actually, the ray doesn't really strike this point because exactly at this very point on the surface of the convex mirror, it is already reflected in that direction. So we only represent, all right, the extended reflected ray that passes through the virtual focus. Now, the other reflected ray, this one, when extended, all right, behind the mirror, there is a point now where the two reflected rays or their extended rays meet or intersect. And that point of intersection is exactly the represents, right, the image of the tip of this arrow representing the object. In other words, all right, we now have the image represented by this smaller upright arrow, right? That is where the image of this object is formed by the convex mirror, right? So obviously it is reduced in size since it is formed behind the convex mirror. It is termed as a virtual image, all right? If you're going to determine the image distance, how far is this image away from the mirror, then we call that the image distance. It's going to be a negative image distance. And a negative image distance, of course, suggests that the image is virtual or unreal, right? And just like the object, the image is also upright or erect, right? So, That explains our answer to this question. All right, so we just would like to emphasize that statement letter A for this question is an incorrect statement, right? Uh, because a convex mirror always forms a virtual image. It cannot form a real image. Likewise, statement letter B is also incorrect because the image formed by a convex mirror is always upright or erect. It can never form an inverted image, while statement letter C is also not necessarily correct. All right. Although there are uh, convex mirrors that are spherical in shape, right? But there are also convex mirrors that are cylindrical in shape. So that makes letter C not an absolute, it is not necessarily correct, right? We already said earlier that the correct answer is option letter D. The image is always reduced in size, all right, regardless of where the object is located relative to the mirror. Question number 5. In a concave mirror, where should the object be placed so that the rays travel parallel to each other after reflection? Option letter A, between the focus and the mirror. Option letter B, at a distance twice the focal length. Option letter C, at the focus. And option letter D, between the center and the focus. The correct answer is option letter C, right? The object must be placed exactly at the focus, all right? So that um, the reflected rays will travel parallel to each other. All right, so to explain why the object must be placed exactly at the focus so that uh, the reflected rays, okay, are parallel and they do not intersect. Okay, the focus of a concave mirror. All right. So as already shown here, here's the object exactly located at the focus, or DO is exactly equal to the focal length F. So starting with a ray that is parallel to the principal axis, the ray coming from the tip of the object, all right, which when reflected from the concave mirror, all right, it's going to be reflected such that it passes through the focus, right? And we need another incident ray, all right, coming from the tip of this object, but has to pass through the center of the concave mirror, right? So we have that ray, the green ray, from the incident or from the tip of the object, but passing through the center. When reflected, it will simply be reflected back along the same path, Alright? And as a result, the two reflected rays, okay, do not intersect. Okay? They are parallel to each other, and that explains why there is no image formed in this particular situation. Question number 6. Which one of the following statements concerning the image formed by a concave spherical mirror is true? When the object distance is, option letter A, less than the focal length, then the image is virtual. Option letter B, when the object distance is equal to the radius of curvature, the image is formed at infinity. Option letter C, when the object distance is larger than the focal length, the image is virtual. And option letter D, when the object distance is less than the focal length, the image is inverted relative to the object. The correct answer is option letter A. When the object distance is less than the focal length, the image is virtual. We have the explanation in just a short while. Here's a summary of the 6 cases for a concave mirror. So, we say that option B is incorrect because when the object distance is equal to the radius of curvature, right, or DO is equal to twice the focal length, we say that the image is formed not at infinity, but rather it is formed um, at the center of curvature of the mirror. That means the image distance DI is just equal to the object distance DO, right? Option C is also incorrect because if um, the object distance is greater than the focal length, right? The image is not virtual, but in fact the image or images for all cases where uh, the object distance is greater than the focal length, right? The images are real. And option D is also incorrect because if the object distance DO is less than the focal length, the image, all right, is not uh, inverted, all right? The image, in fact, is upright or erect. So that means only statement A is correct, all right? Because if the object distance is less than F, then the image is virtual. Question number 7. An object is placed 30.0 centimeters from a convex spherical mirror with a radius of curvature 40.0 centimeters. Which one of the following phrases best describes the image? Option letter A, real and located 12 centimeters from the mirror. Option letter B, virtual and located 12 centimeters from the mirror. Option letter C, real and located 17 centimeters from the mirror. And option letter D, virtual and located 17 centimeters from the mirror. The correct answer is option letter B. All right. The image is virtual and located 12 centimeters from the mirror. All right, so for the solution to this problem, we use the formula for computing the image distance. All right, di is just equal to the product of the object distance and the focal length divided by the difference between the object distance and the focal length, or quantity do minus f. So substituting, we have di equals 30 centimeters, that's the object distance, times the focal length, which is negative 20 centimeters. It is negative because we're talking about a convex mirror. Then, divide this by 30 centimeters, that's the value of do, minus negative 20 centimeters. So if we do our math, we will get the value for the image distance equals negative 12 centimeters. So, an image that is negative means that we have a virtual image, right? That simply means that the image is formed behind, or 12 centimeters behind the mirror, which is a convex mirror. And the last question, question number 8. The inverted image of a light bulb is formed on a screen located 9.00 meters from a spherical mirror. The image is 4.00 times larger than the light bulb. Question is, determine the object distance, or DO, and the type of mirror used. Option letter A. The object distance is positive 0.0278 meters, and the type of mirror is convex. Option letter B. DO is equal to positive 0.444 meters, and the mirror is concave. Option letter C. DO is positive 2.25 meters, and the mirror is concave. And option D. DO is equal to positive 36.0 meters, and the mirror is convex. The correct answer is option letter C. We have the solution to this problem in just a short while. All right. So the question mentions about a screen where the image is to be formed. All right. So the fact that the image is formed on a screen, it means that the image is a real image. That's why you are able to say that the image distance is positive. All right. 9.00 meters, because the screen is 9.00 meters from the mirror. We're also given that the image is enlarged, all right, or is bigger than the object, and that this image is inverted upside down. All right. So before we can find the object distance, we need to emphasize that the magnification or lateral magnification, small letter m, is equal to negative 4.00, right? The fact that the image is inverted, all right, so the magnification must have a negative sign. And we're also told that this image is 4 times bigger than the object. That's why its magnification is negative 4.00, right? And again, using uh, this formula, which relates the object distance, the image distance, and the lateral magnification, all right, our target variable is the object distance dO. So we just equate that to negative quantity di over the magnification m. All right, there is a negative sign outside this parenthesis. So when we substitute, all right, dO is equal to negative quantity 9.00 meters. Di here is positive, all right, and that will be divided by the magnification, which is negative 4.00. So when we do our math, we find that the object distance dO is equal to positive 2.25 meters. As expected, it is positive because the object is located in front of the mirror, right? So 2.25 meters is the object distance, and we are sure that the mirror is a concave mirror. Why? Only a concave mirror, all right, can form a real, an enlarged, and an inverted image. All right? A convex mirror always forms a virtual, reduced, and erect image. So that's it. We are done with this tutorial. So till the next episode, mabuhay, mashallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.